Hello everyone, this is Jingyan Xue from Beijing Normal University. My topic is development of an urban food-energy-water nexus model to support the urban planning. There are 5 main parts in today's presentation. Nexus is a new popular buzzword. According to the nexus literatures, there are 3 main perspectives in the definition of nexus. First is the entanglement over biophysical flows. The second meaning is the problems of scientific inquiry. And the last one is the policy coherence and integrations, which is called the policy nexus as well. However, most researchers nowadays focus on the first 2 parts as a new perspective. The food, energy, water policy nexus is mostly unexplored. Furthermore, there are some problems in the limited FEW policy nexus studies. Firstly, most are static and short-term evaluations, lacking of long-term dynamic assessment. And there are directions in policy nexus pairs. However, the directions are neglected in policy studies. Most of the researches are qualitative, but very few quantitative studies. Therefore, for better management and governance of urban resource, we must consider the directions in urban FEW nexus pairs and develop a long-term dynamic model that can be used to quantify the urban FEW policy nexus. We have developed an online open access tool for the policy assessment of cities. We call it Urban Circular Economy Calculator, which enables to develop different scenarios associated to food, energy, water management and provide long-term evaluation from 1999 to 2049. Using Beijing as a test case, UCEC enables the visualization of calculation of different circular economy pathways. In the upper section, 3 graphs are displayed, containing the information about the trends of asset change, asset density, and area turnover. In the lower part of the page, a specific set of energy, water, and food policies can be indicated by policymakers to create their own pathways. What's more, the options can be chosen multiply. We realize the change of different levels by parameters modification. 3 scenario levels exist under every policy nexus pathway. Scenario level 0 means business as usual, assuming that the government gives policy implementation progress as usual from 1999 to 2049. In the case of scenario level 1 and scenario level 2, we suppose that the efficiency of policy implementation will increase by 10% and 15% with respect to the scenario level 0. Based on the scenario level 0, there appears some adjustment in the parameter setting. The modified parameters are demonstrated in the 6 tables. Taking the food and water systems as a case, we can see the policies of food to water is different from water to food. There are 2 policies in food to water nexus and 3 in water to food nexus. They have different directions. The food to water nexus means the policies focus on food system but will have an impact on the water system. But for water to food means the policies targeted on the water system but will influence the food system as well. In this research, we got some preliminary results. First is about the urban assets. Food to water policy nexus could aggravate the accumulation of urban sites with an increase on the peak value vary from 7% to 16%, but followed by a quicker fall. We can see that the food to water policy nexus may increase the risk of accelerated degradation. In contrast, the energy to water policy nexus could decrease the size of urban sites and slow down the pace of decrease. This simulation revealed that the food-to-energy as well as water-to-energy policy nexus have no considerable influence on the size of urban sites compared with the food-to-water nexus, and vary from 0 to 7%. The water-to-food policy nexus wouldn't influence the urban sites significantly, except for the intensive water-saving farming technology, which leads to a 9% decline. There is a significant shock boom in Beijing's economy under F2W policy nexus scenarios. Similarly, in the food-to-energy policy nexus, the most prominent improvement in the money turns up if 4-in-1 development mode is conducted in the agricultural system. The simulation also depicts that the rate of growth of money will slow in Beijing in the energy-to-water policy nexus category, with 11/14 of these scenarios causing a decline in peak value of money. As a water-saving measure, the intelligent water metering facilities installation shows the most stable state and also a 4% improvement on the money supply, indicating this measure is not only technically feasible, but also beneficial to the money accumulation and economy construction in Beijing. The ecological assets proved to be increased under more than 2/3 of all the selected policies, which is a reflection of more attention being paid on the ecological construction in the development of urban cities. There are no obvious borders between different categories, in addition to the energy-to-water as well as food-to-water policy nexus. The ecological assets would be increased greatly if the policies under energy-to-water nexus being implemented. There would be a boost on the ecological construction in Beijing if hydroelectricity being carried out, with an increase on the ecological assets by 16%. The bottom line indicates the change of ecological assets under rural Kutia development mode, showing a degradation of ecological construction. The simulation of environmental loading ratio presents decreasing trend under all the scenarios, demonstrating that the stress on the local environmental resource will reduce as time goes by. There are three main conclusions according to the simulation result. The environmental loading ratio from high to low is E to W, F to E, E to F, F to W, W to F, and W to E. The hydroelectricity, geothermal energy utilization, as well as onshore wind power present the highest environmental loading ratio. All of them belong to the energy-to-water policy nexus. However, the industrial water reuse technology, household water saving technology, as well as urban recycled water utilization technology, which belong to the water-to-energy nexus, shows the lowest environmental loading ratio, indicating that improving the efficiency or decreasing the consumption is beneficial to decrease the environmental loading ratio. Although the urban circular economy calculator can be used for the FEW policy nexus evaluation, the way to the urban food, energy, water regulation still needs to be explored. The most important two parts in the regulation are the industry from the production side and the household from the consumption side. The domestic water and energy consumption in Beijing is always increasing these years and accounts for approximately 46% and 23% of the total city consumption, respectively. Most studies investigated the nexus at the national and international scale, while limited attention has been paid on the interactions between food, energy, and water at the household scale. But the model for the household scale is special because it needs to capture the impact of diet, the resource using appliance efficiency, and the use behavior on the water, energy, and food consumption. Therefore, we constructed a household food energy nexus model for Beijing. This is a framework which including the household water use and household energy use and interlinks and nexus between the food, energy, and water subsystems. This is a closed-loop diagram of our household food, energy, water policy nexus model, which indicates the relationship and the feedbacks between the three systems, between the different parameters. In the future, we will add some policy scenarios to see its impact on the house resource consumption. Thanks for your attention.